All right, so this is still study guide 1A for the semester final. And we just finished 31 in class, so I'm going to go ahead to the next one, which is number 32. 32. All right, for 32, let me zoom in. They're asking us to graph the function negative 2x plus y equals negative 6 for the domain negative 2, 0, and 2. So first thing, when we started graphing, what is the first thing I asked you guys to do? Solve for what? Y. So we add 2x, we end up with y equals 2x minus 6. But now they give us a domain to use, which means we need to make a table. And the table should look like this. We need an input and an output. And the domain is specific. Here the domain they give us is negative 2, 0, and 2. So let's find the values. Let's start with negative 2. That goes in here for x. So we end up with y equals 2 times negative 2 minus 6. Y equals negative 4 minus 6. What is negative 4 and negative 6? Negative 10. That goes right there. What's my next value? 0. So I write y equals 2 times 0 minus 6. Y equals 0 minus 6. What is 0 minus 6? Negative 6. That goes right there. And the last value is 2. Y equals 2 times 2 minus 6. Y equals 4 minus 6. And what is 4 minus 6? Negative 2. All right, let's plot that. I'm going to start with this one, negative 2, 10. Negative 2, negative 10, that's 7, 8, 9. Negative 10 is right there. Okay. Next one, 0, negative 6. 0, negative 6. And 2, negative 2. 2, negative 2. Okay, but notice on this one they gave us a specific domain. What was the domain? Negative 2, 0, and 2. Those are the numbers they wanted us to use. That pretty much answers the question that follows. Why do you not connect the points on the graph? Danny, why don't we? Okay, close. How about we just write because they only give us a specific domain. Domain 10Q. And what was the specific domain? Guys? Negative 2, 0, and 2. That's why we only plot those. We only draw the line with arrows when it includes all the other points. Does that make sense? All right. Let's go to number 33. Look at this one. Number 33. What is, write the domain of the function. So the domain we know is all the x values. Okay. So the domain is all x values, but in ascending order from least to greatest. What is the first one? Negative 5, comma, next one. Negative 1, comma, next one. 4, comma, and 6. Are we there so far? Next, we need to find the range. The range is all the y values. Y, 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 and y. Once again, in ascending order. Which is the smallest one? Negative 6, comma, negative 3, comma, 2, comma, and 3. And the question they ask, is this relation a function? Explain why. How can we check to see if this is a function? Luz. All right, so we check to see if any x values repeat. Do any of them repeat? No. So that means this is, yes, a function. Why? Because for every input, there is one output. Yes? Yeah. Let's go to number 34. 34. Okay, for number 34, if you notice, it looks almost exactly the same as the one we did earlier, right? But this has a typo. I want you to change it. Look up, guys. Here where it says explicit, I want you to cross it out. And I want you to write recursive. Okay. So now, how does that change? Well, it changes like this. We have two rules that we learned, one for arithmetic sequence and one for geometric sequence. Arithmetic and geometric. The arithmetic sequence looks as follows. F of n equals f of n minus 1. And if it's arithmetic, it's plus d. You guys remember that? Geometric. F of n equals f of n minus 1. But instead of plus d, it's times r. You guys remember those? Yes, Mr. Q. All right, good. Those are the only two types of sequences, of recursive sequences. So let's find out which one it is. So let's see. Going from here to here, from here to here, from here to here, what's happening? What is it? Subtract 15 or plus negative 15. So which one of these has addition and subtraction? This one, right? The first one. So that means our rule is going to be this one, but instead of D, what are we going to write? Negative 15. Yes, Danny? I just said that there was a typo, that we need to change it, didn't I? Okay, yes. I'm sorry? We're number 34. So let's write our rule. Our rule is what? Oh my goodness. F of n equals f of n minus 1. And what do we write at the end? Minus 15. And once again, why did we use that rule? Because that's the rule for arithmetic, for addition and subtraction. This rule over here is the rule for geometric sequence, as if we're multiplying or dividing. Yes? All right, now that we have our rule, which terms are we supposed to write or find? Next three terms. Well, how many terms do we have? 1, 2, 3, 4. So I need to find which ones? 5, 6, and 7. Are we there? Okay, I'm going to zoom out so we can do the work. Here we go. So I'm going to use my function, this one. But instead of f of n, what number goes in there first? 5. So I write f of 5 equals f of 5 minus 1 minus 15. F of 5 equals f of, what is 5 minus 1? 4 minus 15. At that point, look up. What is f of 4, everyone? 95. That goes right there. Bring everything else down. F of 5 equals 95 minus 15. What is 95 minus 15? 80. That goes right there. go to the next one. The next one is for 6. So we write f of 6 equals f of 6 minus 1 minus 15. F of 6 equals f of 5 minus 15. At that point, what is f of 5, everyone? 80. That is correct. 80. Bring down the rest. F of 6 equals 80 minus 15. What is 80 minus 15? 65. And that goes right there. And lastly, which one are we doing last? F of 7. F of 7 equals f of 7 minus 1 minus 15. F of 7 equals f of 6 minus 15. At that point, what is f of 6? 65, so we bring everything else down. F of 7 equals 65 minus 15. And what is 65 minus 15? 50, and that goes right there. We good? Once again, for recursive, you need to write the rule. It's easy to remember. Let me zoom in so you guys can remember the rule. For recursive, there's only 2 rules, arithmetic and geometric. But what do you guys notice is the same on both? The very first part, do you guys see that? They're both the same beginning, this and this. The only thing, this one ends with a plus B, which is arithmetic, and that's if they're adding or subtracting, and this one ends with times R, that's if they're multiplying on the sequence. Okay? All right. Let's go to number 35. 35 was number 5 from the warm-up. So if you want to see this one, go to the previous video. Let's go to number 36. Wait a minute, we did this one also, right? Also go to the previous video to, this one was number 1 from the warm-up for today. Remember that, guys? And number 37 was also on number 2 from the warm-up. So go to the previous video of this one. All right? Yeah. Uh-huh. It's -2 over 1. Yeah. Let's go to number 38. Here we go. Everybody there? All right. This one we already know how to do. But what looks weird is what? Standard form. Is that correct? However, what looks familiar? Write an equation. As soon as you see that, what is the first thing that comes to mind? Y equals mx plus b. Is that correct? Okay. However, what do we need to write an equation like this? We need a slope and we need a y-intercept. Look at the points given. Do they give us slope? No. But do they give us 2 points? Yeah, so that means from here, over here to the side, I can find the slope. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That is blank, minus, and minus. I label my points. X sub 1, Y sub 1. X sub 2, Y sub 2. Okay, let's substitute values. Let's see. What is Y sub 2? Y sub 2 is 2. What is Y sub 1? Negative 4. All right. What is X sub 2? X sub 2 is 0. What is X sub 1? Negative 2. And what do we know here? What is negative times a negative? Positive and positive. Therefore, this is, let's see, 4 plus 2, that's 6. And 0 plus 2, that's 2. What is 6 divided by 2? M equals 3. For right now, we leave it like that, not in a fraction form. We substitute in here. That's 3. Does this sound familiar? Yeah? Do we have a y-intercept, though? No. But do they give us an x and a y value? Yes. Which one do you want to use, the first point or the second point? The second? Okay. So instead of x, what do I write? 0. And instead of y, what do I write? 2. And bring down the rest plus b. Let's see. 2 equals 3 times 0 is 0 plus b. So therefore, 0 cancels. So we're left with 2 equals b. Do I have enough information to write my equation? Yes. So I'm going to write y equals mx plus b, but now I have value, so I'm going to write y equals 3x plus 2. However, look at this part. What is this called? This is called slope intercept form. Is that the form they want? No, they want what? Standard form. So check this out. We need to do something to this equation to make it into standard form. What does standard form look like? When they have the x and the y on one side of the equation. So what do I do at the end? Minus 3x minus 3x. We're left with negative 3x plus y equals 2. This is standard form. So what is the only thing that changed from the other work that we did all those 2 days? The last step, right? Just changing it to standard form. Okay? Let's go to number 39. It says, Daniel, oh yeah, Daniel has $600 in the bank account. Each week, she withdraws $50. It was a typo of mine. I was going to write Danielle. My bad. All right, let me zoom in. So there you go. Danielle has $600 in, oh wait. I did a typo here because this is his and then it's she. Okay. He withdraws $50. Okay. So let's write a linear function. So to write the linear function, we start with f of x. Is that correct? So we write f of x equals. How much is in the account right now? 600. And they withdraw $50 each week. So how do we write withdraw? Minus 50x. This looks similar, right, to the T problem. Remember the T problem earlier? The one where the cup has 64 ounces of tea. Not tea post, my goodness. All right. Then it says, and graph the linear function. Let's graph the linear function. Now, to graph, we can actually make a table. X, f of x. What other way do we know how to graph? Yes? Okay. Is this in slope-intercept form? What do I need to do? Look at it. Loose? Does this look like slope-intercept form? This has to be what variable? Everyone? What does this need to be? Y. How about these? Are these in order? No. So what do I write? Negative 50x plus 600. Okay. So, do we have enough information to graph this here? Yes. Where do we start? At 600. But the slope is what, everyone? 50 down and 1 to the right. So that means, what are we going to go in scales of? You want to go hundreds, even though it's 50 down and 1 to the right? So we go by 50, yes? So let's see. 50, 100, 150, 200, 250, 300, 350, 400, 450, 500, 550, 600. All right. How about the x? We always go to the right by how much? By how much? So we go 1, 2, 3, 4, 5, 6, 7. Let's label this. What does the f of x represent, guys? The y-axis. Look at it. Money. Money. What does the x represent? What's that? No, it represents what? Each week, so we write weeks. All right, so let's plot this. We start at what? 600, so we plot 600. And then the slope tells us to go what? 50 down and 1 to the right. So we go down 50, 1 to the right, plot your point, do it again. 1 down, 1 to the right, plot your point, do it again. 1 down, 1 to the right, plot your point, do it again. 1 down, 1 to the right, plot your point, do it again. 1 down, 1 to the right. We're going to be a little bit off the grid, but that's fine. All right. So let's see. This is 7, this is 8, this is 9, 10, 11, 12. So let's graph this. I'm going to start here, going to here. All right. It says here, find and interpret the x-intercept. What's my x-intercept, everyone? Right here. What is it? What is it? 12 and 0. Let's see. Is that right? Let's see. 7. Yeah, right? Okay. So what does that mean? Danny? At this point, what does it mean? This means weeks. This means money. What does it mean when you get to that point? He has $0 after 12 weeks. That is correct. Bam. Where's my y-intercept? Up here. Who can give me the y-intercept for this one? What is our y-intercept? It's right here. I know, but how do I write it? 0, 600. And what does that mean, guys? at this point? Miranda, at this point, at 0 weeks, at 600, which is 0,600, what does that mean? He has $600 at 0 weeks. That is correct. Next, they want the domain and range. Look up, please. I'm going to start with D. What is my domain, everyone? All x values, right? So where do I start? No. 0, comma, what else? All the way through what? 1, 2, 3. I want you to put dot, 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 12, and close it. Therefore, what is our range? Where do we start? At what? At 0, and then 50, then 100, then 150, dot, 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 all the way to what? 600. That is correct. And that was number 39. And the last one, number 40. This is probably the easiest one. It says, the Environmental Club is selling water bottles $2 for tote bags. So check this out. Water bottles for $2 and tote bags for $5 to raise $100. So they're giving us the equation right there. So look up, please. Water bottles for $2. Do we know how many water bottles? No, but we know how much. Is that correct? So we write 2W. W for water bottle. Plus, what else are they selling? Tote bags. So we're going to write for the bags, letter B. How much are the bags? Do we know how many? No, so we write 5B. And all that to raise how much? $100. Now check this out. I'm going to use a cover-up method. Look up. Why cover up? Because if I cover this up, look, that means that W was 0. What is 2 times 0? What is 2 times 0? That's why I cover it up. So here they're telling me that to make W 0, so I cover it up. What do you see that's left? 5B equals 100. So let's solve this. Divide by 5, divide by 5, B equals 20. That goes right there. Next, I'm going to cover up now the B. What do you see? 2W equals 100. Let's solve. Divide by 2, divide by 2. W equals 50. That goes right there. Over there? However, we can't do that with the last value. What do I need to do? I get my equation. Check this out. 2W plus 5B equals 100. But instead of W, what do I write? 10. So it's 2 times 10 plus 5B equals 100. Let's solve that. 20 plus 5B equals 100. Subtract 20. 5B equals 80. That's my last step. Divide by 5. Divide by 5. B equals what? 16. All right. So let's plot our points. 16. Let's see. 0, 20. 0, 20. Right there. 50, 0. 50. Let's see. 5, 10, 50, 0. I'll be over here. Right? 50. All right. And 10, 16. Let's see. 10, 16 is about right there. Let's graph our line. Does it cross to all 3 points? Yes. Is that it? go. Yes. So for tonight, I want you to go home and go into Nearpod and I want you to practice better the last 20 because I think those are the ones that you guys need the more practice, right? I uploaded the first video, yesterday. Today I uploaded the video for numbers 10 through 31. And right now I'm going to stop this one to upload the second video. Okay? Have a good one, guys. See you guys tomorrow. Bye.